Now, with gravity, let's just say we have the Earth here, and around the Earth, we have what is known as a gravitational field. So I'm trying to draw gravitational field lines. And the closer you get to the center, the stronger the gravitational pull is. So if you're way out here somewhere, gravity has less of effect than if you're here. That's the idea. All right. If we draw a field that's perpendicular to each one of these lines, and I did mean for that to be a different color. Let's see if I can change that color. All right, I did mean for that to be a different color. Then you'll have what is known as a potential. We call these yellow lines potentials. Let me draw another one. Oh, not that. All right, there's another potential. And I'm just going to use these colors to separate them. Okay, so the first potential is right here. We're just going to call that U sub 1. The second one is right here. We're going to call that U sub 2. And the third one is right here. We're going to call that U sub 3. So we can have this idea of potential difference. We have some U3 minus U2, or we could have U2 minus U3. There's a difference between these potentials. The idea is as long as you walk, or as long as you move an object along this surface, you don't have to do any work against the gravitational field, and the gravitational field doesn't do any work against you. Same here, and the same here. So if you think about this like in terms of Earth, if you walk along the ground, you don't really feel the Earth's gravitational pull on you, and you don't really have to work against it. If you go to a building and you take the elevator to the second floor, same kind of scenario. And then if you take it to the third floor, same kind of scenario. As you're walking on that floor, you don't feel it. So we conceptualize this as a potential. It's a place where things are not doing, gravity is not doing work against you, and you're not doing work against gravity. Or gravity is not doing work on you. That'll probably be better stated. And you don't have to work against gravity. That's the idea. All right. So we've so far defined our gravitational field here, and we defined potential. We've also defined potential energy before, and that's just M times G times Y. Okay, so that's going to be our potential energy. It's typically delta Y, but we just going to go with Y, making the assumption that Y sub 0 is just 0. Okay, so we have gravity, we have our acceleration here, we have our potential energy here, and we have potential here. And the only other thing that we need to present is this: M1 ME over RE squared. So F sub G can also be written as M1 times G, as long as you know that G is equal to capital G times M sub E over R sub E squared. We should have discussed this in the last lecture. Cool? Now, taking this, if you understand this pretty good, let's go ahead and do the same thing for charge. If you have a charge here, and let's just say it's pretty much overwhelming, you're going to have an electric field. If the charge is positive, let's just say that it's negative. If the charge is negative, the electric field is going to go to the center here. All right. So that's if this item has a charge Q. It's just like if it had a mass M.